What's going on, everybody? James here from Artificial Entertainment, and welcome to another Unreal Engine 5 tutorial. And today we're going to be looking at the environmental query system, so let's go ahead and dive in. So I have here a third-person project. I've created a simple AI, just a controller, blackboard, behavior tree, all that stuff. There's nothing EQS related, and there's nothing in the behavior tree either. It's all empty, so we're going to be starting from scratch. I just created the base components. And so what we're going to be doing today is I want to go over the EQS system. Now I'm going to go over all the generators, different things that you can do with them, and then show some demonstrations of things that you can do as well. Because realistically, the environmental query system is something that is truly amazing. There's so many things that you can do and so many different detections you can set up for your AI that I really wanted to kind of do a better video about how to be able to really utilize different pieces of this system. Now, one thing just to state is that this is an AI function. This is something for NPCs, for AI. This is not for your player character. So this is the reason why I just set up a simple AI. If you guys are interested in learning how to be able to make AI, I have a series on that, and I'll put a link at the bottom of this video. But today is all about that EQS. So let's go ahead and get started and start talking about what it is. Now, the basis of what the EQS is that it's a generation of detection of multiple different styles that can return back either an actor, object, or location value. Now, this is very powerful because it's something that is a constant run, but runs a lot more effectively than something like an event tick function. And it runs usually inside of the behavior system, which makes it even better. So let's go ahead and make our first EQS so I can stop talking about it and show you guys a little bit more. So to be able to make one, all you gotta do is right click, go to Artificial Intelligence, and click on Environment Query. And then we'll just name this Test EQS. And then we'll double click and open that up. Now, one thing you'll notice when you open it up is that it does look very similar to a behavior tree. Now, the reason why this is because, well, it's meant to function very similar to a behavior tree, but when you pull off the root, you're going to notice that you have a list of generators. And even though this might say composite, it doesn't work like a composite inside of a behavior tree. And we're going to go over the composite one last, just because you need to really understand the rest of these before you're really going to start jumping into this. So the first thing we're going to talk about is probably the most simple of them all, which is the actors of class. So the actors of class query, what this is essentially allows you to be able to generate in a radius a detection to see if there's any type of specific actor or any actor type or object type or anything that you're really looking for. And that can all be changed under the details panel. Under generator, go to search actor class, and you can change it to any actor type or blueprint type or a whole bunch of things. In all honesty, you have skylights, you have a whole bunch of different things that you can actually have it look for. Now, you can also have it just look for it on like across the board, but you can also make it so it's only going to generate actors in the radius that you set, which you can set from this value here. 500 is usually a good starting value, but depending on what you're trying to do, you might want to increase or decrease this. And then as well on this, you have the search center. Now, this by default is going to be whatever the AI character that's going to be initiating this query is going to be, but you can make your own context queries so that way you can have it search or start from a different location. We're going to talk about making your own context here in a little bit, but I just want to let you guys know that you can use this to be able to generate a list of actors around the AI, around another object, and honestly, it limits your imagination. So that's the actors of class. Very basic, very simple. And the next one I want to talk about is going to be the perceived actors component. Now, we used this in the AI series when we made the detection system. And the reason why I like to use this is because it's basically a detection component that is going to be built into the behavior tree rather than being coded into the controller. I have found that this is a lot more effective when trying to spawn multiple AI if you have it all running through the behavior system. So that's the reason why I like to use this node as the controller for setting of certain values based off of if we do or do not see something. Now, the one thing to keep in mind if you use the actors query is that you need to make sure that you actually have the environment or the AI perception component inside of your controller. So if I open up the testing AI controller, you're going to see I have AI perception. I don't have anything in it yet, but actually I will go ahead and put in the site config just really quickly because we are going to want this later. So we'll go ahead and just do a detection by affiliation, select everything, max age of 1, and then we'll just compile and save that. Now, again, you want to make sure, so if we're going to set up something that allows us to have detection of sight, for example. So if we go back to our EQS here, we can actually set the sense to use to whatever we want. So if I set it to AI sense sight, but I don't have sight listed on my controller, this will not work because all of the information that this query is going to use for its detection is actually going to be based off of the AI perception system inside of your controller. So all of this information here is still going to be used. It's just going to be, rather than going through the controller, it's then going to be pushed into this EQS and used here instead. Now, this is very important to know because the next option up here that I want to talk about is the search radius. So -1 means that it's going to reduce the value of the cone that's going to go out for the AI sense of sight. Now, what this means is that it's going to reduce it. I don't really know what the exact values systems are for the search radius, but from what I've seen, I'm estimating that it's right around -1 is going to half size it. 0 is going to make it so that way the cone is the standard normal size or whatever settings you set it within the controller here. 1 would be doubling it, 2 would be tripling it. This is sort of what I've discovered so far. I have not been able to actually prove of whether or not this is 100% accurate, but it's reasonably accurate to go by. So -1 is going to reduce it by half, and then 0 will just make it so that way whatever settings you have inside of your actual perception component are going to be what it runs off of. Now, and just like all the other ones here, we have the allowed actor of class. We can set this to just any actor type that has the AI perception stimuli source component. However, we can also set it to a simple BP third person character if we wanted to, because this way we can have it so it just detects the player character. So you can have this set up so that way it's going to detect very specific blueprint actors or any actor that or any blueprint that is of an actor type or any other type that you're really wanting to look for. But again, the main thing to remember is that your AI has to have the stimuli component, and the thing that you're trying to have it detect has to have the AI perception stimuli source. So those are two very important things that have to be in there in order to make this work. But as long as you have those, you can use this very easily. Now, the last one I want to talk about before we start getting into actually how these get put together, I am going to talk about all of these, but like the points grid, it's better. It's a different system we're going to use to show you guys that. So what we're going to talk about now is going to be the current location. Now, the current location is actually very, very simple. Like I said in the beginning, the EQS can return either a actor list or a vector location list, but that is it. One thing to keep in mind is that most of the time when you set up an EQS, it'll return a type of an actor. However, this is specifically a location value based off of whatever context that you set. So this is the reason why I wanted to go into this next, because this allows me to be able to kind of explain how contexts work within the system for the environmental query. So now just a quick overview as to what this is literally just returns the current location of whatever it is that you're setting as the query context. So what we'll do is we'll go now and make a context for our EQS. So I'm going to go to my EQS here. I'm going to right click and I'm going to go to blueprint class. Now what we're looking for is we're just going to type in context and we see env query context underscore blueprint base. So this is what we want, the environment query context. And we'll take that and just name this player context. Now, if we double click and open this up and we go over to the My Blueprint section, under the functions, you're going to see an override option. And this allows you to be able to provide a single actor or location, or as well as a array or multiple locations or actors. So this is where location actor set or single actor, single location. Now, what this means is that if you're using multiple actors, you need to have some sort of an array function or something like that. But a single actor is all we really need when we're using for like the player character, and it's just a single player game. Now, as you can see here, we have the query or object, query actor, and then resulting actor nodes here. Now, all we really need to do is we're going to pull off the resulting actor, and then we're just going to get player character. And we'll go ahead and slide this back just like so. And what it'll do is the resulting actor will just be our player character, which for us is going to be the BP third person character. Now, what this is going to do is allow us, if we go back to our EQS, we can now go the query context, we can set this to players. So now what this will do is return the current location of our player. So we'll start with this one, we'll save this, and we'll go to our AI behavior tree. Now what we're going to need is a vector location key in our Blackboard, because again, this particular EQS only returns a vector, does not return an actor set. So what we need to go is new key, scroll down to vector, and we're going to type in player location. And then what we're going to want to do is go to behavior tree. Off of the root, we're going to add a selector, and then we're going to add two more selectors, one on each side, because we're just going to set it up so that way if the EQS finds something, it'll shoot off to one branch, and if it doesn't, it's going to shoot off to a different branch. And if you guys have watched any of my AI videos, you know how we're going to do that. It's going to be just through a simple Blackboard decorator. So we're just going to go to the Blackboard base condition, and we're going to look for if player location is set. So that's going to be the thing that it's going to look for. So if our EQS sets a location value, we want it to shoot over here. And then what we're also going to do is add decorator, and we're going to go for conditional loop, because we're going to have it execute this over and over again while player location is set. And then what we'll do is off of the selector, we'll just do a move to, Set the Blackboard key for the move to player location, put the acceptable radius up a little bit just because it's usually really high. And then after the move to, we'll just put a simple wait function, setting it to about 2 seconds because we don't want the wait to be too long. Now, so what we've done is just made it so that way it knows where to switch it, but we haven't given it the information yet. So what we're going to do is to our main selector here, the bottom gray node, we're going to right click, go to service, and run EQS. Now, the way that this works is that whenever you put a service EQS onto a selector, it's going to run this even while it's executing these other branches. So even though this is still, the execution might be down here, it has to run through this selector. So wherever you have these services, you can actually control how often or how it actually runs the information by just intelligently placing your EQSs. So what we can do is click on this, go to the EQS request under the details panel, and we're going to select our test EQS. And then under the Blackboard key, we'll set that Blackboard key to player location. So now we'll go ahead and save, and I do have a nav mesh here, so we can just go ahead and click on play. But now you'll see that player location is set, and he's moving to me. Now this allows us to be able to do basically the same thing as, setting the player location, but I'm just showing you guys how this works with setting like a vector value and then setting a context. You could do the same thing rather than getting the player character. You could cast to something or get actor of class, and then you could put the return value into the resulting actor like this. You could select from any actor that you want. And this allows you to be able to get the actor of a specific kind within that value. So there's a lot of things you can do by just, again, intelligently setting up your contexts. But the one thing I do say is that if you're trying to set up something where you're going to get a location value, but you might sometimes also need an object value, just set it up as an object value versus a vector value. So on the overrides here, use single actor or actor set. Don't use location set unless it's only a vector value that you're going to be using. And it's only a vector value that you're actually going to be saving. So these are the things that you do want to keep in mind when doing this. But that's really all this is. So with the queries and the context, you can use these to be able to set the location where the query is going to happen, and then what it's going to do, and then the execution for what it does after it finds that information. So let's go ahead and change, instead of current location, let's go ahead and we're going to look at the perceived actors type. So we're going to set this to BP third person character, and we're going to set the sense to use to be AI sense site. And then we're just going to click on save. Now we do have to add the AI component to our third person character. So we're going to go BP third person character here and just open this up, go up to add, and then we're just going to add the AI perception stimuli source. And then under AI perception, register as source for site. Compile and save. So now what we'll do is we're going to make another Blackboard key. And this one is going to be an object key with the name of player. We'll change the key type from object to actor. Now, what this is going to allow us to do now is be able to get an actor value instead of a location value. So we're going to set the Blackboard key to player, and we'll change these Blackboard values to if player is set instead of player location. And then the move to we'll set to as player. So it's basically going to have the same function, but instead of player location having a vector value associated under the Blackboard key information down here at the bottom, we'll have a player object value under here instead. So if I go ahead and click play, I will have to run around my AI so that's way he can actually see me, because right now the player location is invalid. And yeah, so as you can see, as soon as I got into site, BP third person character underscore C underscore 0 is set as the player type. I can just keep moving around, minimize the thing here. But yeah, as you can see, he's following me, he's doing whatever he's supposed to do, but now I have a Blackboard object value rather than a vector value. And you don't need to use the third person character. You can use anything you want. You can use other, like a blueprint of some kind for like a workstation. You can use anything you want with the EQS system as far as setting the specific actor values for the perception component. So the last thing that we want to talk about is going to be on the EQS itself. We're going to talk now about utilizing the points system. Now, the points are essentially it's going to generate a bunch of points around, but the reason why we're doing this now versus doing it with the AI character is because it's actually an easier way to be able to really see what's going on. So what we're going to do is under the test EQS, we're going to add a different generator, and this one's going to be the points grid generator. Now we're also going to go ahead and remove the EQS off of our AI's behavior tree and take our AI out of the world completely. Because for the EQS, now this isn't necessary, but it does make testing these a much more of a breeze. So we're going to go into our assets here just so we can all stay in the same folder. And we're going to go right click, blueprint class, and we're going to look for EQS testing. And you're going to see EQS testing pawn. So we'll click on this and then click on select. And we'll just name it testing underscore pawn. Now what we're going to do is we're going to drag this into the world here, drag it up a little bit so that way it's on the proper height. And then if we look, kind of scroll down under the details section, you're going to see that we have an option here for query template. So we're going to change it from none to test EQS, and now you'll see that we have a grid that is being generated. And you can already see that the grid is actually being affected by certain things that are actually affecting the nav mesh, such as this here and this ramp here. Now, one thing that's really cool about the points grid is we'll go ahead and bring this back up here. Now, you can change the size of this grid by doing a few different things. First thing is the grid half size. So we'll change this to 100. Now, as you can see here, 100 by 100 kind of puts it right dead center. But if I go 100 by 75, as you can see, by changing the space between, it makes more or less areas of detection, because each one of those spheres is essentially like its own little sphere detection, right? So if I go and set this to 125, you can now see that because of the space between is larger than the grid half size, it's no longer in the middle where it should be. But if I set this from 100 to 250, now you can see that it's back into the center. So there is a bit of a mathematical equation that happens between the grid half size and the space between. Realistically, make sure that the space between is roughly around half of whatever the grid's half size is, and you'll pretty much make sure that your grid is always dead center of whatever you're trying to use it for. So now one thing we can do with these, you can do this on any one of them. All of the generators that I've shown you today, you can also do this with, but it's just easier to show you the visual example when doing it with the grids. So we're going to right click and you're going to see something here that says add test. And from here, we've got distance, dot, tags, overlap, pathfinding, a whole bunch of stuff here, right? Now, the one thing that's really cool is that if we go and hit trace, query or trace on visibility, and we set score only, and the trace data is basically what this is going to do is set up a line trace, and it's only going to line trace things that are actually going to be able to be hit by the collision system for, let's see, visibility. So that's the trace channel. So you can use custom trace channels in these too, which is pretty cool. But if we go to our BP third person character here, we'll drag an instance of him into the world, but we also need to change the collision because right now by default, the BP third person character does not collide with the visibility channel. So we're going to go collision presets, set it to custom, and then we're going to set it to block the visibility channel. So now if I go back, save, now you can see that this is getting a 0 because this is getting hit by our testing pawn. So if I take the testing pawn and I move it, you see now that's 0. If I move it back, it's all 0. So this is basically just showing which one of these is actually being hit, but there's not a lot of information that's happening, right? There are not really a lot of things going on. So what we're going to do is change it to filter and score, and now you'll see that now it's getting a result of 1. What we can also do is add another test. We're going to add a distance check. Now this distance is going to be score only because we want it to basically, what this is going to allow us to do is, as you can see, distance to querier, prefer greater. So this is the querier. It's checking and seeing that, okay, we have their AI or our player character right here, and then it's going and, all right, well, that's a little too close. We want this instead because it's going from the distance. Now, we can also go distance to, and we can choose that player context as well if we want. Now, as you can see, though, it does create a little bit of an issue where these are both being scored as 1. Now, that's not entirely a bad thing, but it does make it very difficult for it to properly set location values. You want these to be scored with one of them being higher than the other. So if we go filter and score and put it back to the item, put it into the query there, and then now what we'll do is set it back to score, and now you can see here that we have 1.8, 2.0. So now we're actually getting it to score something based off of that distance value. And this distance, as you can see, is 3D distance. We can go 2D distance, distance Z. So you can actually really kind of control what that distance value is going to be but it's really up to you. But this is where that grid kind of comes into play by adding in these tests and just kind of telling it, okay, I want to get this distance. I want to get whether or not it's actually able to, detect something. Is it hitting any of these traces? So like distance is just that. It's the distance from point A to point B. Dot is actually the general code dot, where it's going to get a rotation value. So this way you can return back and get within a certain rotation value. Gameplay tags, overlap, path, all of these are pretty basic. Like I said, I'm not going to go into every single one because realistically, the query system is so complex that I could be here for about 4 hours showing you guys just a fraction of what you can do with the system. So that's why I wanted to make a video that was more about showing you guys how to be able to, utilize certain portions of it, but how you use it and actually making it a functionable system, that's on you guys. Now, one thing to note as well is that if I go ahead and I delete this, go off of the root, you can see that we have circle, cone, donut, as well as grid and pathing grid. Now, one thing to keep in mind is that these are all the same. The circle, cone, donut, grid. These are just shapes, okay? That's the only difference. If I put it to a circle, you'll see it's going to put it out in a circle. If I put it out to a donut or a cone, it's going to do it into a cone. So it's really just dependent on what you need for your detection as far as size and shape go. Because as you can see, the cone goes out a lot farther with the way that it actually, distributes its points. But the one on here that is actually different than the rest is the points pathing grid. Now, as you can see by default, it comes out very large. So we're going to turn the grid half size down to about 150 with the space between being 125. Now, as you can see, the grid is going to look for anywhere that it can't go, but if it can go, it doesn't do anything. So this is really the difference between the path and grid, because you can go path to item and use the data binding here to go query params. So this way, if it does actually get the path correctly, you can do things with that information. You can also change the nav filter as well to make it so that way it's only going to use on certain navigation meshes. And the projection data, this is something you don't necessarily get with any other type of query other than the grids. So, or not the grids, the point system. So these are really, really good too, where you can actually change the projection height up and down, go up a little higher from the ground or a little lower. So it's really all up to you on how you set this up. Now, the pathfinding option, this is where it gets really cool, is that you can actually set the scan range multiplier to 1.5. We'll set this to 3, and then we'll save. Now, what you'll see is if I go in, I have to be a lot closer to that object now, and then if I get too close, it's going to try and find one of these points here. So what essentially that scan range multiplier does is that it increases the sort of buffer distance around these points. So rather than having to be exactly on the point, you can set it up to give it a little bit of a kind of a buffer period, a buffer vector area. And this just makes it so that way you've got a little bit more room for error in case something happens. So I always suggest turning the scan range multiplier up a little bit, just so that way you don't have any issues down the road. So those are all the main functions. Now, the last one that we're going to talk about is the composite node. Now, the composite node, the reason why I saved this for last is because if we click on this, you're going to see that we don't have anything here. We can right-click, add tests, and do all that stuff, but it doesn't really have any information being generated, because if we look over on the details panel, we can actually add generators this way, and we can add as many as we want. And we have all of the options that we would normally have right here. So we can choose an actor of class, plus a current location, plus a points donut. Click on save, and that'll be exactly what'll happen. It'll generate a points donut with an actor class and all that good stuff. Now, here's the problem with composites. When you set up multiple of these, what's going to happen is you're only going to have one blackboard key. So if we go back and look at the blackboard or the behavior tree for our AI here, and if I just go right click, run EQS, and we put that EQS back in here, even with 4 different actual services, or 3 different services being run, we only have one blackboard key. So that's something to keep in mind, is that if you can't use this to set up like 5 or 6 different Blackboard keys being set up within the values, but you can use multiple different queries to be able to set up the individual keys. So there's sometimes a little bit of extra work, but the fine tuning that you get out of using this system is so, so good. No, so that's really it, guys. As far as the EQS system, it's pretty simple. You're just going to go in and try to, give it an actor type or give it a location value, and then just run that in your behavior tree. Now, one other thing that I just wanted to point out is that you don't necessarily just have to run it off of a selector or a sequence or whatever, because you can run the service of EQS. You can run this on any of the composite nodes, or actually even on a node itself, on a task. So you can even run an EQS while he's moving to the player. So this is something you can add these to any node in the behavior system. And while that node is running, it's going to run the EQS. But you can also pull off of any of the selectors and have it run a single instance of an EQS. So it'll just run it once, return a value back, and this way it's not a consistently updating value. And sometimes that's good, because sometimes you just want to have it find something and then keep that information for a long period of time, even if it's not necessarily still in range. You want your AI to know that it's still there. Well, this is how you can do that, by running an EQS whenever it's near something and making sure that to set that value either back or to. So you can set them up off of services off of the actual composites, or you can set them up off of their own tasks themselves, and you get the same options where you can choose the EQS that you're going to run, as well as the Blackboard key that's going to set. So that's really it, guys. EQSs are awesome. I love them. So I hope you guys found this video informative. If you have any questions or any further information that you're looking for about the EQS functions, please go ahead and ask. I am looking for some ideas for different videos to do about the EQS series. I'm going to be doing one about how to be able to make an AI find cover and some other cool things, but always happy for more suggestions from you guys. But that's going to close it out for today, guys. Hope you